Yeah, okay, great. Andrea, if you want to get started.
Yeah. Our website is called Predicting Airline Satisfaction. Our goal is to predict whether someone was satisfied or not with their flight using machine learning. In the top left corner, we have a button called AI Camp that takes us to the main page of AI Camp. And in the top right corner, we have buttons that take us to the different sections of our website. And so in the About section, we explain what our website is about and how we're going to solve our problem by using visualizations and models. In the Use section, we explain what we used for our project, which was Kaggle, Python, and so on. And the Our Dataset button takes us to our original dataset from Kaggle.
So for our project, we made lots of visualizations, including pie charts. So this is a pie chart between satisfied and neutral/unsatisfied based on onboard service. So as you see on the left, it's lots of 4s and 5s, which means it's good, while on the right, it's mostly spread out. So this pie chart shows the amount of people riding in each class. As you can see, most people ride either business and eco class with a small amount of people riding eco plus. This is the pie chart between the amount of genders riding on airlines. This is to be expected. It's mostly 50-50 with a slight lean towards females. This is the same thing as the first chart, except with departure and arrival time and the convenience of those. This seems to be mostly equal between the two, so that means it doesn't have much to do with the overall satisfaction. This is the same thing except with legroom service. The 4 and 5 takes up about 3/4 of the chart on the satisfied section, while in the unneutral or unsatisfied section, it's around spread out with a lot more 1s. And the same thing again, except with with in-flight Wi-Fi service. So the satisfied chart is around half 4s and 5s, while the neutral and unsatisfied chart is more spread out, except for the fact that there's very little 5s. And these are 3 donut charts showing short, mid, and long distance flight and the type of class that they rode, correlating to these. So the short distance flight, you're likely to ride eco class with some people riding business. Mid distance flight, it's a little bit more 50-50, while in favor of business class, there's a chance you'll ride eco. And with long distance flight, you're almost 100% gonna ride business class.
Sebastian?
Apologies, I had muted my microphone.
That's fine.
This diagram about satisfaction in class. Business class, you're more likely to be satisfied. In eco and eco plus, you're more likely to be neutral to dissatisfied, though. This is just the amount of people who are both satisfied and not satisfied. The lean to neutral or dissatisfied is likely due to it being 2 options. This is an age and satisfaction histogram. Ages 39 to 60 are more likely to be satisfied, and all other ages are more likely to be neutral to dissatisfied. Flight distance and satisfaction. Something to note here is the later flights are more satisfied. That's like because they're being taken by business class people, and people in business class generally enjoy their flights. On this arrival delay and satisfaction, there doesn't appear to be much of a difference between the two, though. This is customer type and satisfaction. Loyal customers are much more even, while disloyal customers have a higher chance to be dissatisfied.
So this is a box and whisker plot showing the type of travel and the flight distance. So if you ride, if your type of travel is for business, then you're going longer distances, and the longer distances tend to be more satisfied, likely because they're riding business class. While with personal travel, it's more or less the same for both satisfied and unsatisfied. This has to do with gender and age. With age, you can see that most people are writing between 25 and 50 years old, while with that's for unsatisfied, and while satisfied, you're more likely to be satisfied if you're older, and it's around the same for both genders. And this has to do with the age in the class. Once again, the age is the same, around 25, maybe around 50, while with eco class, you're more likely to be satisfied, while with business class, you're a little bit like the ages are more compact because more people writing business class are older.
This shows arrival and departure delay and satisfaction. The greater the delays are, the more likely they are to be dissatisfied. This is a scatter matrix that shows our continuous variables. Most of them don't correlate except for the delays, but that's to be expected. And this is a correlation matrix which shows how much each variable correlates. 0 is no correlation, 1 is a positive correlation, and -1 is a negative correlation. The only columns and rows particularly care about are the satisfaction rows, and the most notable one is online boarding and business class, which each have a 0.5 correlation.
To make accurate predictions, we tested a multitude of classification machine learning models. Based on each model's precision, accuracy, recall, and F1 scores, we chose the most effective model to be deployed on the website. Throughout our testing, we used hyperparameter tuning through grid search CV to optimize the effectiveness of each model on our specific dataset. First, we tested a random forest model, which averages randomized decision trees to create a final prediction. Second, we tested a categorical naive Bayes model, which assigns probabilities to each feature to create a prediction by applying the Bayes theorem. And third, we tested a decision tree model, which makes a tree of conditionals based on training data and applies the testing data to the conditionals to get a prediction. These are the same decision trees that the random forest model uses.
And then we used a k-nearest neighbors model, which is a classification model that works by finding the distance between a piece of testing data and all the training data in the data set. The model then finds which class the majority of the k closest data points are in and classifies the testing data point to that class. And after that, we used an ADA boost classifier model, which makes a bunch of smaller models that perform about as good as random guessing. After each week learning model is made, it makes predictions on the testing data, and the predictions that the model gets wrong are given a heavier weight. So the next week, the model will focus more on those and get better results.
Next, we made a logistic regression model, which is a classification model which determines probabilities, and when testing data is placed on the graph, the position of the testing data outputs a probability that the model uses to make a prediction. And then we also use a stochastic gradient descent model, which is a classification model that optimizes how another model works while adds more regression or classification functions underneath the model to optimize accuracy.
For our results, we showcased our models and metrics in a table. And some trends that we noticed was that table or tree-based models did better than the other models, and the search grid helped, or the grid search helped the SGD, but it didn't help the tree model. Our worst model that we found was the KNN, and our best model was the random forest. In conclusion, our team worked very hard even though we had little to no coding experience. And our first step was, 1, we created visualizations and we understood their trends. 2, we made models, found their best parameters and hypertuned them. And 3, we found our best model, which was the random forest, which had a 95% accuracy, 94% precision, recall, and F1 score.
And we have the flash site running, so I just put in a lot of values because it's just like too many to kind of go through. And so we hit this predict button. I think it should. We scroll down. I'll take a second. Yeah,
So we got a 1, and that makes sense. From our data, I put in basically lots of 1s lots of 5s. So people were very happy with their experience. So yeah, that's our airline satisfaction project. I'm really proud of the Frenzy physicists. Great job, everyone.